this is the area. Okay, likewise over here, right, the area, so this is also our area, the shaded region. Are we clear? Okay, so two different forms of formulas. Okay, so it's all dependent on how or where the shear force is acting. The first one that we drawn on the left, the shear force is acting on the y direction. The next one, the shear force is acting in the z direction. Okay, I want to highlight this. Right. Okay. Now we go back to just the shear force coming from the y-axis, or the y from the top. Okay, I'm going to copy the diagram again. So the shear force is coming down from the top, right? So this is our Vy, right? So for this case, the area starts from furthest away from the distance. The area, this is the start of the area. Okay. Y is your slider. You decide where you want to stop. It's a variable, right? So over here, this is the end of the area of interest, right? Okay. So now we are going to find, so the formula again is the shear xy is equal to shear yx is equal to Vy over Izz Qz T. And a straight easy thing to do now, we know that the thickness T is equal to what? V. Okay, because parallel to the ZZ axis, this is our thickness. Okay, the thickness of our area of interest. Okay, so now we are going to find QZ. Okay, QZ is equal to a y bar. Okay, and as you can see, the y bar is exactly at C prime. Okay, the y bar is exactly at C prime, which is the centroid of the shaded area. Okay, that is okay. So now rule number one now. Okay, the datum is not at the top or at the bottom. The geometry datum, as you can see down here, right? Everything starts from Z, or everything is measured relative to Z. Okay, so datum. So rule number one, right? The geometric datum right is at the centroid. Okay, that is the geometric datum, right? So we want to find, pardon me, can you put this as A prime? Okay, so now we want to find the area A prime. Okay, so A prime is equal to B multiplied by C minus Y. All right, so B is equal to C minus Y. So what I like to do is usually this is my width, and this is my depth. Okay, so in this analysis, this distance, so parallel to the ZZ axis, this is my width. Perpendicular to the ZZ axis, this is my what? Depth. Same like second moment of area, like how I taught you guys. Okay, same. But an interesting feature is this. We start with C. Okay, well, let me highlight. We start with C, and then we minus Y. Okay. The reason we do that, so this term, okay, this term over here, right, the yellow term will be what? Will be positive. If we do Y minus C, right, this term over here will be negative. And physically, it's not possible to have a negative area. Or yeah, negative area, right? It has to be a positive area. So with that, we created rule number 2. Okay, so you got rule number 1, that the geometric datum is at the centroid. Rule number 2, okay, let me highlight rule number 2 now. Because the area has to be positive, okay, we come up with rule number 2. So rule number 2, okay, the analysis will start from C or Y max, right? So C refers to this, right? Y max refer to the distance from here to here, right? This is our Y max. Okay. So the analysis direction, right? The analysis direction now, this is our analysis direction. Analysis. Okay. This is our analysis direction. Okay. So so based on like what I showed you, based on how we derive the equation, right? It's C minus Y, right? And we know that C is equal to what? Y max. Yes or no? So the analysis will start from C or what? Y max. That is why the area, right? The area, so if this is the first area, the variable Y will be sliding towards the what? The centroid. So that is rule number 2. Okay, this is so these rules are not made by me. It's how the equation has been what? Derived. Very important. Okay, rule number 2. Okay. And then the next one, the next thing that we're going to see, okay, we're going to see how are we going to calculate the first, we're still looking at the first moment of area. Okay, we're still looking. So now we are going to find Y bar, right? So we done with our area already. Area is easy. So Y bar, right, is equal to C plus Y multiplied by 0.5. Okay, C plus Y multiplied by 0.5. So if you cannot remember that, I can't remember that for sure. Okay, I want you to have a concept of deriving. Okay, or how to get the centroid. Is it C plus Y or C minus Y 0.5, or why is it C plus Y? Okay, so if you call this 3, at this point is 3, right? At this point is 5. The centroid has to be what? 4, yes or no? Right? It's between 3 and 5. So this is equal to 3, right? So C is 5, sorry, 5 plus 3 multiplied by 0.5. So that's why this is equal to 4. So that's why Y bar is equal to C plus Y multiplied by 0.5. Okay, simple things to help you remember stuff. Okay, very simple stuff. So Q, the first moment of area about the z-axis is equal to a prime y bar. So a prime is equal to b, right? C minus y, c plus y, right? And then multiply by 0.5. Okay. So if I rearrange this, you get 0.5 b, right? And then you have c squared minus y squared. Okay. And the analysis, okay, the analysis was stopped at the centroid. I repeat again, the analysis were stopped at the centroid. Y was stopped at the centroid because y now becomes what? 0. There is no minus y. I repeat again, there is no minus y. Okay? Y is always positive. So if you want to analyze from, I call this top and bottom, right? You want to analyze the top over here. This for both, this is the what? Datum, right? And this is the analysis direction because it starts from Y max or it starts at C. At the bottom, the analysis will start from the maximum or the most extreme position from the centroid. Okay. So the next rule that we're going to make, okay, because the analysis was stopped at the centroid, is the analysis for the first moment of area. Okay, so this is rule number 3. Okay, so rule number 3. Yeah, rule number 3. The analysis for the first moment of area cannot cross over the centroid. Okay, it cannot cross over the centroid at all. So what do I mean by that? Okay, what do I mean? So let me highlight rule number 3. On. Oh, I do apologize. Okay, why do I need to apologize? So this is rule number 2. I've spoken to you about rule number 1, which I did not highlight here. Okay, I will do this. So this is rule number 3, and this is rule number 4. My apologies. I'll tell you what is rule number 1. So rule number 1. Okay, my bad. Okay, so rule number 1. Okay, let me go back a bit. Okay, rule number 1 is this. Okay, so rule number, I'm going to write rule number 1 over here. Okay, so rule number 1 is that the V and I are constant okay, are constant regardless. Okay, regardless on the point of analysis. Okay, so this is rule number 1. So what does it means? If you are analyzing at different points, the different cross-sectional points of the, so for example, if we have a T-beam, right? This is a cross section. If you want to find out the shear stress at point A or the shear stress at point B,